Hey guys, so cool update here with the compressor bypass valve for the eBoosters. I've got some of the silicone coupling still disconnected, and it's in test fit mode. I'm about ready to tack weld. But what I'm talking about is this guy here. It's that 90 millimeter, what is normally an electronic throttle body. It's been revised a bit to work as a compressor bypass valve. So it'll normally sit open, which maybe I'll look from the underside here. So in this system, the air enters the air filter right here. All the air to the engine always goes through this large compressor stage on the S400 SXE. So it comes out here, and then this is where it's got a chance to go two different directions. So normally this valve is open, so the air can go both through this valve and straight up to the engine. It also can branch off to that T that's above there, and then splits again to these two eBoosters. Those are also compressor stages, and then it merges back in. So normally cruising down the road and putting around, and also at high RPM when the turbo is doing all the work, this valve is open and the air is just flowing from the turbocharger. It's being compressed and going up to the engine. But when the eBoosters are commanded on, which is going to be low RPM, slightly off idle through maybe about 3,500 RPM or so, as soon as these guys get commanded on, this valve will close. And when that happens, that forces all of the air that is going through the big compressor stage on the turbo. Of course, it can't go through here, so it forces it to go only through that upper path. So then at that point, these eBoosters work as a high pressure stage. So turbo won't be boosting really at low RPM because it doesn't quite have enough turbine energy. So pressure's not coming out, not much pressure is coming out here. But as soon as that air enters the eBoosters are going to pressurize it upwards of about a 1.45 pressure ratio. So let's say 7 pounds of boost peak, and force that up to the engine. And of course, this valve forces all the air to go through the eBoosters, as well as prevents any air that the eBoosters have boosted or pressurized from being able to flow backwards up through the either compressor stage or essentially just sit here and recirculate, which is what would occur if that valve wasn't there. So one step closer. Of course, now I got a tack weld, so it's welding this flange all the way around, and then this O-ring coupler, welding him all the way around. So I'll get him to be positioned nicely where the throttle body is, or bypass valve I should call it, is sitting nice and level. And then pull everything back off and fit it up permanently. Then I just need to wire it up and get the additional scripting in my Arduino set up to be able to control the throttle body, and then tune it. Of course, I'll need the 48-volt system online for the eBoosters, and that'll be sometime in April this year. So hope that helps.